Okay, we'll have a look at the calculations on percentage yield and percentage atom economy. If we start off with just what the equations are, you'll have to learn these equations so you won't be given them in the exam. Percentage yield is the actual yield divided by the theoretical yield times 100. So what you'll actually have to look for, the actual yield is what you actually make, so that's usually given in the question, or if you're doing a practical you might have weighed what your actual product was. The theoretical yield is what you could expect to make if you had 100% conversion. So usually they'll give you a starting mass for one of the reagents and you'll have to work out from the equation ratio how much you could theoretically made given an ideal world. An example then, what is the percentage yield if 119 grams of chloroethane is made from 70.0 grams of ethene, when the equation for this reaction is C2H4 plus HCl goes to C2H5Cl. The first thing to do is to work out the theoretical yield from your equation. So if we look at the equation, we'll see the ratio of ethene to chloroethene is 1 mole makes 1 mole. This is often called a 1-to-1 ratio. So in this reaction then, we can have a look in the equation and read from this that 1 mole of ethene makes 1 mole of C2H5Cl. We just ignore the HCl as this is not needed in this particular question. Once we know how many moles once we know the ratio, then we can work out how many moles of ethene you actually start with. So if you remember the equation, the amount of moles equals mass in grams over mR. In some questions, because of the large industrial process, they may give you the mass in tons. Provided you start off with tons in this equation and you finish with tons as your answer, you can use it because the ratio would be the same. So in this particular question, we can work out the amount of moles of ethene, which is the mass of ethene in the question, which was 70.0 grams, divided by the mR for ethene, which is 28.0. This gives us an amount in moles of ethene is 2.5 moles. We know from the equation that 1 mole of ethane would make 1 mole of chloroethene, so therefore 2.5 moles of ethene to start off with will make 2.5 moles of chloroethane. Now we know the product is 2.5 moles of chloroethane, and this then can be converted into a mass by rearranging the first equation. So we now know that mass in grams equals amount in moles multiplied by the mR. Just remember that the mR is for the product now, which is chloroethene. Don't use the same mR as you did before. Once you've worked that out, that would be 2.5 moles of chloroethane times 64.5 for the mR equals 161.25 grams. This is the actual theoretical mass. So given that you started off with a certain mass of ethene, this is how much you would be able to make in an ideal world. We never do make the theoretical mass, but it's just so you can calculate your yield. So in a practical or something, often in the method of the practical, you'll find the information of how much you start with in moles or in grams of your reagent, and you can work out the theoretical yield of your product from the equation. Step 2. Use your percentage formula again to work out the percentage yield. So the percentage yield equals actual yield divided by theoretical yield times 100. So if we read in the question, the actual yield in the question was 119 grams, and we worked out the theoretical yield being 161.25 grams. So if we put that in the equation, the ratio times 100 is 73.8% to 1 decimal place, 3 significant figures. If you are given a mass in tons, you can just use the same process and your answer will obviously be in tons. We talked about that before. But also if they give it in kilograms, the same principle would work. Going on to another example then. If we look at percentage atom economy, the percentage atom economy, I've just written AE here, equals the MR of the desired product divided by the summation of all the MRs of the reactants. That sign there at the side means summation, that means add it all up, times 100. So if we quickly look at this, the MR of the desired product, don't forget that will include the balancing number. And the summation of all the MRs just means you add up the MRs of everything that's on the left-hand side of your stoichiometry equation. Okay, an example. Calculate the percentage atom economy for the production of iron from iron oxide from the following equation. So we've got Fe2O3 plus 3CO goes to 2Fe plus 3CO2. We are only interested in the Fe as the product, and we're interested in everything on the left-hand side. So I would start off with adding everything, all the MRs up from the left-hand side. So I'd have Fe2O3 plus 3 lots of CO, add those up. And then I would do 2 times the Ar for iron as the interested product. So percentage atom economy, don't forget the 2 times the 55.8 for the iron, divided by the MR for Fe2O3, which is 160, added to 3 lots of carbon monoxide at 84, times 100, then would give you 45.9%. So that's obviously your atom economy. If there is only one product in the percentage atom economy, will be 100% then, because everything's managed to get into the product. So a good example of this would be C2H4 plus H2 going to C2H5OH. So that would be 100% atom economy. Obviously, when you do this in practice, your percentage yield wouldn't be 100, so you wouldn't get a complete conversion. So what do these actual values tell us? The percentage yield tells you how much material is lost due to the manufacturing process. For example, material is not reacted properly and some of it left unreacted, or perhaps it's sticking to filters, or perhaps it doesn't recrystallize out. These sort of factors would reduce your percentage yield. Percentage atom economy will tell you how many of your atoms in your reagents end up in the products you want. Obviously, if they don't end up in the products, they're going to end up in a byproduct, which is often wasteful. So the higher the percentage atom economy, the better reaction. So chemists will look for several different ways of making the same chemical, which improves the percentage atom economy, and they'll also look at the technique, which would obviously improve the percentage yield. And based on this, they would decide on a good process for manufacturing.